Recall that probability distributions describe what probably will happen instead of what actually did happen. Now, we've seen how to calculate the mean and standard deviation of a probability distribution just in general, and let's review that again. So for a probability distribution, we said that the mean was equal to the sum of the x times p of x. Each value of the random variable times its probability, and we sum that up. The standard deviation we found was equal to the square root of the sum of x squared times p of x. All of that minus the mean squared. So once we have the mean, then we can calculate the standard deviation. But for the specific distribution called the binomial probability distribution, these calculations are a little bit easier and less complicated. The mean is just equal to our number of trials times the probability of success. And the standard deviation is equal to the square root of the number of trials times the probability of success times the probability of failure. Recall that the probability of failure is just 1 minus the probability of success. Okay, so let me write those things down real quick. So N is the number of fixed trials, P is the probability of success, and Q is the probability of failure. 1 minus P, probability of failure. Alright, so if we know we have a binomial probability distribution, we can use these simpler calculations. So let's look at an example where we get a chance to use those. Okay, in the past, Gail has made 80% of her free throw attempts, and we're going to assume free throw attempts are independent. We're going to look at a trial of free throws. Now in this case, we're not drawing free throws and then sampling those with or without replacement, because clearly these are things that are something that happens and we can't replace them. We're actually starting back at 0 each time, but assuming that they're independent, in other words that the fact that she maybe misses one doesn't affect her ability to get the next one. That's what we're going to have to assume here in this problem. Okay. So we want to find the mean and the standard deviation for this procedure. If the number of free throws, if the number of trials is 415. So N is equal to 415, and the probability of success, her probability of success in the past was 0.8. 80%. Okay, so the mean is equal to the number of trials times the probability of success, so 415 times 0.80, and that actually comes out to exactly 332. Now remember our rounding rule. We round to one more decimal place than the values of x. The values of x are integers, whole numbers, 0, 1, 2, 3, all the way to 415. So therefore, we would round to one decimal place, but this comes out to be a whole number, so we'll just leave it at that. And our standard deviation is going to be the square root of NPQ. So the square root of 415 times 0.8 times 1 minus 0.8. which is 0.2, right? And this comes out to be 8.1. I'm going to say approximately because we are rounding to that 1 decimal place following our rounding rule. Okay, now we have that information. We have the mean and the standard deviation, given that she's been successful 80% of the time, so out of 415 attempts, that would be her mean and standard deviation. Now the next question. Well, this season she made 307 of her 415 free throw attempts. Is this consistent with her past record? In other words, is this within her usual range? Okay, or is this value of 307, so let me just say that, is 307 within her usual range? So that should tell us something. We need to use the range rule of thumb to find the max usual and the min usual value for this procedure. Okay, so recall that the minimum usual value is equal to the mean minus 2 standard deviations. Okay, and the max usual value is equal to the mean plus 2 standard deviations. Alright, so let's see what the min usual value would be. That would be equal to the mean, 332, minus 2 times 8.1, and that comes out to be 315.8. The max usual value, 332, plus 2 times 8.1, and here we get 348.2. Okay, so I want to make sure we're getting this and help you understand. Let's just look at a number line to what we're saying here. If this is our mean, 332, okay, this is the mean, then we go out 1, 2, let me mark these, so this would be plus 8.1 plus 8.1 to get to our maximum usual value. So this value would be 340.1, and then this value would be our 348.2. Okay, and then going the other direction, we go minus 8.1 minus 8.1. These are the standard deviations, right? Plus 2 standard deviations, minus 2 standard deviations. So the first one would be 323.9, and then we get our 315.8. And so now we can clearly see that our usual values are in this range. Anything above that would be unusual, anything below this would be unusual. Okay, maybe I'll mark that. That's unusual, and here, unusual. Okay, so that's a visual of what we're trying to say with the range rule of thumb. Find the mean, add 2 standard deviations, and subtract 2 standard deviations to find your minimum and your maximum. Okay, so the question was, if she made 307 out of 415, is this consistent with her past record? And we would have to answer no, because 307 is below her minimum usual value. So the answer would be no, 307 is below Gail's minimum usual value, or usual number of free throws. Let's just bring it back to the problem. made. Okay?